This method is difference of squares factoring. So to use difference of squares factoring, we need a couple things. We need a difference. That means we have subtraction. Between the two terms, we need two terms. And we need perfect squares. So example 4, a squared minus 64, that's a difference. And both a squared and 64 are perfect squares. So then we plug into the pattern, which p squared minus q squared, we turn it into p plus q, p minus q. So we take the square root of each of the terms to find the p and the q. So in this case, the square root of a squared is a, the square root of 64 is 8. So that means that p is a and q is 8. So we'd set up a plus 8, a minus 8, and that would be the factored form. So example 5, p squared plus 9, those are perfect squares, but this is a sum and not a difference. So that actually means that this polynomial is prime, which means that it's not factorable. So we can only use the difference of squares pattern when we have subtraction or a difference between the terms. Okay, problem 6, 98m to the third n minus 50mn. Right now those are not perfect squares. However, we can take out a GCF before we start with the difference of squares factoring. So in this case, the GCF that divides into both the numbers would be 2. And we can also divide out an m from both terms because they share 1 power of m, and we can divide out an n. So we would divide both terms by 2mn to get 2mn multiplied by 98 over 2 is 49. M to the third over m, one of the m's would cancel out to give us m squared. N over n would cancel. And then minus 50 over 2 is 25. And then m cancels and an n cancels. Okay, so now we do have perfect squares within the parentheses. So 49, the square root is 7. M squared, the square root is m. And then 25, the square root is 5. So that means that 7m is the p and 5 is the q in the pattern. So we write 7m plus 5 and then 7m minus 5. And then we write the GCF that we took out, which was 2mn, out in front.